All right, so more problems based on triangles. Let me read this little section to you first. You can use the relationship among the sides of a triangle to determine whether the triangle is acute or obtuse. Given A, B, and C are the sides of a triangle with C as the longest side, that's very important. I'm going to highlight it. C is the longest side. So you have A, B, and C being the longest side. A and B, it doesn't matter which one you label, okay? When C squared is less than A squared plus B squared, so in this case, this is C squared being less than A squared plus B squared, the triangle is acute. So that means acute means an angle that's smaller than 90 degrees. So this angle right over here, that's smaller than 90 degrees. And when C squared is greater than A squared plus B squared, so over here, this is an obtuse angle. Obtuse angle literally just means angle that's bigger than 90 degrees. And so when you have that, C squared is greater than A squared plus B squared, you have an obtuse triangle. And then of course, if you have C squared equal to A squared plus B squared, that is a right triangle. So just using this as a reminder for us, let's try out number 5 and 6. Okay, so we're going to graph ABC, the triangle ABC, using each set of given points, and then we're going to determine if triangle ABC is a right triangle, an acute triangle, or an obtuse triangle. So let's graph A, graph B, graph C. Well, it's such a tiny triangle, but let me zoom in here. Okay, so for this vertical side length, you can count the boxes and you can see that the side length is 2. For this one, you can count the box and see that the side length is 1. For the third side length, it's a little bit harder to tell. So let me actually label my points. 3, 2, this one is A. 2, 4, this one is B, and then this one is C. Okay, so I labeled it because I want to know which points am I connecting to find this diagonal side length. So I'm connecting A and B. So I'm going to use these 2 points and I'm going to plug those into my distance formula so that we can actually get the value of the so we can get the value of the length. So square root x2 minus x1 squared plus y2 minus y1 squared Okay, so remember this is your x1, y1, x2, y2. So we have 2 minus 3 squared plus y2 minus y1, so 4 minus 2 squared. So 2 minus 3, that's negative 1 squared. And then 4 minus 2, that's negative 2 squared. Negative 1 squared is 1. Negative 2 squared is 4. 4. Oh my gosh, it doesn't like it when I write. And I'm just going to leave it as square root of 5. Okay, and so let's leave that as the square root of 5. And then when we are determining our A, B, and C in terms of here, A, B, and C are the sides of the triangle with C as the longest side. So our longest side is the square root of 5. So this is our C value. And then you can just literally label the other sides A and B. It doesn't matter which one you choose as which. But here I'm going to say A is equal to 2. I just chose that side length. B is equal to 1. And C is equal to square root of 5. So we're going to plug it into the formula. And our formula is A squared plus B squared. And then we're going to compare that to C squared. I'm just going to use the equal sign here. We don't know if it's equal yet. But remember, if A squared plus B squared is equal to C squared, then we have a right triangle. If C squared is less, we have an acute triangle, and then if c squared is greater, we have an obtuse triangle. So let's see which one we get. Okay, so a squared would be 4 because it's 2 squared. B squared would be 1 because b is 1. And then c squared is square root of 5 squared. So let's figure that out. So square root of 5 squared, the squared and the square root cancel each other out, we get 5. And then when we add together 4 plus 1, we also get 5. So 5 is equal to 5. That's great. The c squared is equal to the a squared plus b squared. So since c squared was equal to a squared plus b squared, we have a right triangle. I'm going to write right triangle. Okay, so I'm going to pause the video here and then, or I want you guys to pause the video and try out number 6 on your own. Okay, unpausing, let's take a look at number 6. So here we have 3, 1, this is your A, 3, 4, that is your B, and C is 0, 1. This is your C. Oh my goodness. Okay, so I really wanted you to try this out on your own. Okay, so if you try this out on your own, you will find that this is a 3, you can count the boxes. This is a 3, you can count the boxes. And when you use the distance formula, we've got plenty of examples of distance formula, so I think you guys can do it on your own. This third side length between C and B, you would get square root of 18. And so, let's test it out. Square root of 18 is your C, and then we can have this one be your A and B. It really doesn't matter. So we have C squared, and we're going to compare that to the A squared plus B squared. And let's see if it's equal, or if it's less, or if it's greater. So C squared, square root of 18 squared is going to be 18. And let's figure out if it's equal to A squared plus B squared. So A squared, here's A is 3. When you square A, you're going to get 9. B squared, so B is also 3. So when you square that, you're going to get 9. And then that simplifies to 18 and 18. So luckily for us, again, these are equal, which means that we have a right triangle because C squared was equal to A squared plus B squared. So I'm going to write right triangle. Okay, so that's it for this video. Remember to call me over if you have any questions.